Greetings of the day. Myself C P Shanthanikethan, Assistant Professor in the Department of Mechanical Engineering from Adiman College of Engineering, Autonomous. Let us discuss on centroid from engineering mechanics. What is centroid? A centroid is the geometric center of any shape. It is the point where all the medians of a shape intersect. A median is a line segment that connects a vertex of a shape to the midpoint of the opposite side. Centroid are used in engineering to determine the center of mass of objects, which is important for structural stability and balance. In simple words, it is the point where the whole weight of the body acts. So center of gravity, it is used for 3D objects, whereas centroid is used for 2D objects. So in this table, let us discuss some of the centroids of 2D planes, 2D plane figures. So if you take a rectangle, graphically or geometrically, the centroid of a rectangle can be found out by connecting the diagonals. Yes or no? Likewise, here the rectangle analytically, the centroid can be found out by using the equation x bar comma y bar. X bar comma y bar represents the centroid coordinates of the centroid. So here for rectangle, x bar equal to b by 2, y bar equal to h by 2. And if you see the area of rectangle, the formula to calculate area is b into h. Likewise, triangle, for right angle triangle, your coordinates of centroid are b by 3 and h by 3, whereas area equal to bh by 2. The next circle, x bar comma y bar, the coordinates are d by 2 comma d by 2, area is pi by 4 d square. Then semicircle, then x bar, here the x bar equal to d by 2. You can see here the leftmost portion of the semicircle, the distance x bar is nothing but d by 2, whereas y bar equal to 4r by 3 pi, the distance from the bottommost portion to the center of the semicircle. Y bar is equal to 4r by 3 pi. In other words, it can be written as 0.424 r. Likewise, quadrant, the x bar coordinate is 0.42 r and y bar is also 0.424 r. Then trapezium, you can see here the trapezium in the figure, it is given the distances a, b, h, height h, and a and b are the two different sides of the trapezium, and the formulas to calculate the x bar is a square plus b square plus ab by 3 into a plus b, whereas y bar equal to 2a plus b by a plus b into h by 3. So these are some of the standard formulas to calculate the centroid of simple plane figures. Now let us discuss the how to find out the centroid gravity or centroid of composite plane figures. That is combination of two or more simple plane figures, that is known as composite plane figures. So the formula to calculate the centroid of composite plane figures is x bar equal to a1x1 plus a2x2 plus a3x3 up to n divided by a1 plus a2 plus a3 up to n. Similarly, y bar equal to a1y1 plus a2y2 plus a3y3 plus etc. up to n divided by a1 plus a2 plus a3 plus up to an. So here a1, a2, a3 represents the areas of different sections, and x1, x2, x3 represents the distances of each section from the y-axis, and y1, y2, y3 represents the distance of each section from the x-axis respectively. Now let us discuss the problem on centroids. So a uniform lamina shown in is consist of a rectangle, circle and a triangle. Determine the center of gravity of the lamina. All dimensions are in mm. So this is the given lamina. So in this lamina you can see there are three simple plane sections. One is semicircle, next one is rectangle, and then a equilateral triangle. So all its dimensions are given. So before starting, first draw the y-axis and x-axis to this problem. Draw the x-axis to the bottommost portion of this section and y-axis along the leftmost portion of this section. So after drawing, let us take the first portion, rectangular portion. So to find the rectangle, L into B, yes or no? So L into B, rectangle L is 100, B is 50. 100 into 50 is 5000 millimeter square. Then x bar, the formula is x1 equal to L by 2, y1 equal to h b by 2. So 100 by 2 and 50 by 2 will give you some. 100 by 2 is 50, 50 by 2 is 25. So while finding out x, you see that when you draw the leftmost portion y-axis to this section, composite section, the rectangular portion is 25 mm away from the y-axis. So that's why we are adding 25 to it. So when you add 25 to it, 25 plus 100 by 2 is 75 mm. Then similarly, so for the semicircular portion, area of a semicircle is pi by 2 r square. So pi by 2 into 25 square will give you 982 millimeter square. Then to find x2, that is centroid of the semicircle, x2 is equal to, here the diameter of the semicircle is along the y-axis. So your x, while finding out x, the distance is from the diameter to the center of the semicircle. So that is 4r by 3 pi. Because it is inverted here, so you have to just subtract from the total radius. So 25 minus 4r by 3 pi. 25 minus 4r by 3 pi will give you 14.4 mm. Then similarly y2 is nothing but d by 2, 50 by 2 equal to 25 mm. Then for the triangular portion, half bh, so half into 50 will give you 1250 millimeter square. Then x3 is equal to, you have to see the bottommost portion and the leftmost portion of this triangle. So when you see the leftmost portion of the triangle, it is not intersecting with the y-axis of the whole composite section. So it is away from the distance 25 plus 50, that is 70 mm, 75 mm. So then also you have to add 25, so it is totally 100 mm. So 100 mm. Then y3, if you see the bottommost portion of the triangle, it is also not coinciding with the bottommost portion of the whole composite section. It is away from the distance 50, so add 50, 50 plus 50 by 3 will give you 66.7 mm. Now add all these three answers, you will get x bar equal to 71.1 mm, then y bar equal to 32.2 mm. We will see one more problem. A semicircle area is removed from a trapezium as shown in figure. Determine the centroid of the remaining area. So in this problem, from the trapezium, a semicircular portion is removed. So you have to just subtract the semicircle from the trapezium. So what I have done is, I have divided this composite section into three parts. One is rectangle, second one is right angle triangle, and third one is semicircle portion. So I can add 1 and 2 and subtract 3. So first I will take rectangle. So rectangle area is L into B. So L is equal to 80 into 30. Then x1 equal to 80 by 2 and y1 equal to 30 by 2. So we'll give you 40 and 15 respectively of the rectangular section. Then triangle A2 equal to half BH. So we'll give you 1200 millimeter square. Then here x2 is equal to 80 into 2 divided by 3. Okay, then y2 equal to 30 plus 30 by 3. Why we are adding 30 here is, if you see the bottommost portion of the right angle triangle, it is not coinciding with the y-axis of the whole composite section, x-axis of the whole composite section. That's why we are adding 30 to it. So 30 plus 30 by 3. Okay, then semicircle, if you see the leftmost portion, it is not coinciding with the y-axis. Again you have to add 40 here for finding x3. So you can see here x3 is equal to 40 plus 40 by 2, then y3 is equal to 4r by 3 pi, that is equal to 8.5. so which can be substituted in the formula for composite sections. X bar equal to, as I told earlier, you are adding 1 and 2 and subtracting 3. So here a1 plus a1 x1 plus a2 x2 minus a3 x3 divided by a1 plus a2 minus a3, that is the formula. So we can find the answer as 41.1 mm. Similarly for y bar equal to, so in place of x substitute the value of y here. So a1 y1 plus a2 y2 minus a3 y3 divided by a1 plus a2 minus a3 will give you 26.5 mm. So one more problem, this is very important problem in centroid as well as in moment of inertia. So this is an I section. So sometimes the diagram will not be given, so just in theoretically they will give you bottom flange, top flange and web. So this small rectangle at the top is known as flange, and the bottom one is also known as flange, and the one which is connecting the top and bottom, that is known as web. So its dimensions are given. So there are 3 rectangles here. So the first thing is name the 3 rectangles and find the areas of each rectangles and its distances from the leftmost edge. So if you see the bottom flange, its area is 30,000 millimeters square, and y1, why they have found out only y means, you can see it is symmetrical about the y-axis. It is symmetrical about y-axis. Then in that case the value of x is same for all the 3 sections. So for the first section is also 150, and for the second one is also 150, then the third one is also 150. So likewise here find only values of y bar. So a1 y1, a2 y2, then a3 y3. So y bar equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. So we'll give you y bar as 160.7 mm. Okay. So likewise you can find the centroid of any composite plane figure by combining the simple plane figures. Thank you.